So far we've been talking about atoms themselves and have been kind of forgetting about this whole category of species called ions. But consider the size of the ions when they're gaining or losing electrons. So of species when they're gaining or losing electrons and becoming ions. Well, cations, when they lose electrons, they tend to want to go to the noble gas core that is to the left of them on the periodic table, right? So like lithium wants to have the same number of electrons as helium. When that happens, all of the electrons in that outermost shell are stripped away, and so you essentially lose electron shells. Anions, they tend to want to go to the noble gas core that is to the right of them on the periodic table. And so anions, they'll pick up extra electrons and will essentially have the same number of electrons as that nearest noble gas. So oxygen will go from a atomic radius of 0.73 angstroms. When it becomes the oxide ion, it'll go to 1.26 angstroms. And remember how this works? We have equal number of protons and electrons in the atom itself. When it becomes an ion, it'll either gain or lose an electron. In the case of sodium, it's going to lose a single electron and then have 11 protons, which each have plus 1 charge, 10 electrons, which each have minus 1 charge, and so we get a sodium ion. This is how we write a single sodium ion. So the ionic trend is that when cations are formed, they get smaller, or they are smaller than their parent atoms. And when anions are formed, they are larger than their parent atoms. So if we were to think about this for a second and consider a problem like this, if you were to ask to arrange magnesium, calcium 2 plus, and calcium in order of decreasing radius, well, first off, you'd need a periodic table, and then we'd have to consider when it goes from an atom to a cation, does it increase or decrease in radius? So let's go here. Let's go get our periodic table. So it's magnesium, which is found here, calcium, which is found here, and then the calcium 2 plus ion. So calcium is further down, so we have more electron shells, so that would be the largest of those three species. When we form a calcium ion, a 2 plus ion, we're losing 2 electrons, and so we have the same number of protons, and so basically we have the same number of protons pulling in fewer electrons towards itself, and so you would expect that it would constrict, it would shrink. And so calcium 2 plus would be the next biggest thing, and then the smallest of those three would be the magnesium, just because it has fewest electrons of all of them. So going back to the question, range this in order, we would have calcium's the biggest, calcium 2 plus is the next biggest, and then magnesium 2 plus would be the smallest.